when you are writing one function in terms of another, so g of x in this case is going to be written in terms of f of x. So we're going to have g of x equals something f of x, but then we're going to have a bunch of things that's happened to f of x. Well, maybe not a bunch, but all the transformations that happen to our blue function so that it becomes the dashed function, the solid to the dashed. So it looks like there's a reflection. So we'll keep track here. So we reflect across the x-axis. But if I do that, that's just going to make those points come down here. So there's a little bit more. It looks like it's shorter than it used to be. The center didn't change, or the vertex didn't change, so it didn't go right, down, or up, or left. But if we compare these new dots from just a reflection to these dots, if you compare the y values, like here and here, I usually look for where it crosses right on a grid line, so it's easier to compare the difference. So the y value here, or you can compare it right or left, but I'm going to do vertical because it just lined up really nice. So the y value here is 2, or -2, compared to the y value here, which is -6. So if I'm going from -6 to -2, what am I multiplying by? Which is 1/3 of the distance. So let's check to make sure that's the same thing here. This is -1, this is -3. So again, it's 1/3 of the distance. So we have a vertical compression by 1/3. So because our y values are 1/3 of what they were when I just reflected across the x-axis. And it looks like that gets us to our dashed line. So we have reflection across x, so just negative in front, vertical compression by 1/3, which is also in front. All of this is in front. So negative, and the 1/3 also goes in front of f of x. And there we go. There's our g of x.